Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video explains the decision criteria we use to resolve a hypothesis test. Let's get started. So, in the previous mini lectures, we've examined significance levels, critical values, test statistics, and p-values. And these are numbers that we can use to conduct the actual hypothesis test. So the way we're going to conduct the test is by comparing a pair of values. And we don't just take any two values. We have to compare like with like. We want to compare apples with apples, oranges with oranges. So here's what we do. We can compare the p-value with the significance level alpha, because these are both areas under the curve. So the p-value is an area, the significance level is an area, so we got like with like, and we can compare those two. Alternatively, we can compare the test statistic with the critical value. Remember, the test statistic is the boundary for the area that is the p-value, and the critical value is the boundary for the area that is the significance level alpha. So here we're comparing area with area or boundary with boundary. Either way, we've got like with like, and that makes for a fair comparison. So either way we do this, okay, we're going to come out with the same result. And we're really trying to answer the same question. Are we inside or outside the region of rejection? So the region of rejection is that critical region. That is the area under the curve and the tail of the distribution. That is the significance level alpha. That critical region is the region of rejection. So if we're inside that rejection region, we're going to reject the null hypothesis. If we're outside the rejection region, then we fail to reject the null hypothesis. It really is no more complicated than that. So that's what we need to understand, because that's how we conduct the hypothesis test. So let's say we want to use the p-value, and we're going to compare that then with the significance level alpha. Well, in this case, okay, if p-value is less than or equal to alpha, so alpha is the fence, and if you're sitting on the fence or you're on the left side of the fence, then you're going to reject the null hypothesis. Alternatively, if you're on the right side of the fence, because your p-value is greater than alpha, you're going to fail to reject the null hypothesis, because you're outside that region of rejection. If instead we use the test statistic and the critical value to compare for our hypothesis test, then we're going to say, okay, so if the test statistic's inside the critical region, we're going to reject the null hypothesis. And if the test statistic is outside the critical region, then we're going to fail to reject the null hypothesis. So again, same concept, just a matter of, which pair of values you're going to use for your comparison. But the basic concept is the same regardless of which route you take. Okay, we're going to reject the null hypothesis when we're inside the critical region, and we fail to reject H0 when we're outside the critical region. That's the basic concept. Let's look at some visual representations of what we just got done describing, because I think this will help a lot of students to understand better the concept of what we're looking at here. So let's start by looking at the p-value. When we compare the p-value with the significance level alpha, we've got an area that we're comparing with an area. Okay, so if we're inside the region of rejection, which is the critical region, we can fit the p-value area inside the significance level area. Okay, this is the same thing as saying what we said earlier. The p-value is less than or equal to alpha. If, on the other hand, the p-value is greater than alpha, then the p-value is an area that's larger than alpha, and we can't fit it inside that significance level area. So therefore, we're outside the region of rejection, and we're going to fail to reject H0. So let's say the p-value is smaller than the significance level alpha. Okay, so that means we're going to reject the null hypothesis, because we can take that p-value and fit it inside the significance level. So imagine them like two different areas, and we take that p-value area, and we can fit it inside the significance level. We are therefore inside the rejection region, and we reject the null hypothesis. Alternatively, if our p-value is greater than our significance level, then that's going to lead us to fail to reject H naught. Because when we look at our two areas and we try to fit that p-value inside the significance level, oh, it's bigger. It can't fit inside. And so therefore, we're outside the region of rejection and we fail to reject H naught. Likewise, we can have a visual representation for our test statistic. So we use our test statistic, we're going to compare it with the critical value. So these are boundary values that we're comparing, values on the horizontal axis for a distribution. And we're comparing the one with the other. So the critical value, remember, is the boundary for the significance level area alpha. And the test statistic is the boundary for the area that is the p-value. So we take that critical value and compare it with the test statistic. And this is how it plays out. So that critical value is going to provide the boundary for the region of rejection, because alpha is the area of that critical region, and that critical region is the region of rejection. So the critical value provides the boundary for that region of rejection. If our test statistic falls outside the region of rejection, then we're going to fail to reject the null hypothesis. Alternatively, if our test statistic is inside the region of rejection, then we're going to reject the null hypothesis. Okay? So you can see that regardless of how we're doing the comparison, whether we're using areas or boundary values, it doesn't matter. We're going to use the same concept. If you're inside the region of rejection, you reject the null hypothesis. If you're outside the region of rejection, you fail to reject the null hypothesis. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.